Bitcoin. You've definitely heard the name, you've seen the crazy headlines, but how does it actually work? Under the hood. So let's forget the hype, forget the price charts for just a few minutes. Today, we're going to break down the core mechanics of how Bitcoin actually moves value across the globe, without a single bank getting involved. Let's start with the fundamental problem it was designed to solve.
So, think about this for a second. How do you send something digital, like a photo, to someone? You just make a copy, right? You hit copy, paste. But you can't do that with money. You have to be absolutely sure that once you've sent that $10, you can't just send that exact same $10 to someone else. In the real world, a bank takes care of this. But how do you do it digitally without that trusted middleman? That's the real puzzle.
The entire Bitcoin system, and I mean the whole thing, is built on one simple, powerful idea: the transaction. Everything starts right here. So let's get this part crystal clear.
Now, a Bitcoin transaction isn't quite like sending digital cash. It's actually more like writing a check and then pinning it to a giant public bulletin board for the whole world to see. It's a signed, public instruction that just says, hey everyone, I authorize this much value to move from my address over to this other address. And that public part, that is absolutely key.
This is where the difference really starts to sink in. A bank transaction? That's private, tucked away on their servers. A Bitcoin transaction? Totally public. A bank can reverse a charge if something goes wrong. A Bitcoin transaction? Nope. It is final and irreversible. And maybe the biggest deal of all, a bank is the middleman in a normal transfer. Bitcoin is direct, person to person, no middleman needed.
So every single transaction goes through these three basic stages. First, someone, let's call her Alice, she uses her private key, which you can think of as her unique digital signature, to create and sign the payment instruction. Then she broadcasts it out, not to one place, but to the entire network of computers. And finally, it just waits in line to be verified and made official.
Okay, so that last step, the confirmation part, this is where things get really, really clever. A single transaction doesn't just get approved all by itself. To make the system secure and efficient, it gets bundled together with hundreds of others into something called a block.
So, when you broadcast your transaction, it doesn't get confirmed right away. It jumps into this kind of global waiting room, often called the mempool. Just picture this huge, constantly changing pool of pending transactions from all over the world, all just waiting to be picked up and processed. And someone has to do the work of organizing this queue.
And this is the perfect way to think about it. All those waiting transactions need to be written down somewhere permanent, right? A block is simply the next blank page in this giant, shared, public accounting book. The goal is to fill that page with transactions from the waiting pool.
So who's filling the page? That's the job of the miners. Now, these aren't people with pickaxes. These are powerful, specialized computers all around the world. What they do is grab a bunch of those transactions from the global pool, and then they all compete with each other to be the one who gets to add the next official page to the ledger.
Okay, so we've got transactions, and they get put into these blocks, or pages. But how do you stop someone from just sneaking back and changing a page later on? This is where the chain part of the blockchain comes in. And honestly, it's pure genius.
To earn the right to add the next block, these miners have to prove they've done a massive amount of computational work. They're all competing in a global race to solve an incredibly difficult math puzzle. The first one to find the solution wins, gets to add their block to the chain, and as a reward for all that work and electricity, they get some newly created Bitcoin. That whole process, that's mining.
Now here's the crucial security piece. Every block, once it's filled with transactions, gets a unique digital fingerprint. It's known as a hash. This is a code that is completely unique to the specific contents of that block. If you change even one tiny little detail, a single comma in a transaction, that entire fingerprint changes completely.
And this is what creates the security. The next block in the chain, let's say block 28, has to include the unique fingerprint of the block that came right before it, block 27. This creates a cryptographic seal, literally chaining them together. You can't alter block 27 without changing its fingerprint, which would instantly break the chain's link to block 28, which would break the link to block 29, and so on. Any tampering would be immediately obvious to the entire network.
And there you have it, the blockchain. It's not just a database, it's a time-stamped, chronological chain of these sealed blocks. And this chain creates a permanent, unchangeable, and public record of every single transaction that has ever occurred.
So we've built this unbreakable chain of history. But who holds it? Where is this ledger actually stored? The incredible answer is, it's kind of everywhere and nowhere in particular. There isn't one master copy of this ledger stored in a bank's vault. Instead, there are thousands of computers, we call them nodes, spread all across the globe. Anyone can run one. And each of these nodes holds a full, identical, and constantly updated copy of the entire blockchain. This radical distribution of information is the absolute key to the whole system.
This design gives the network three really revolutionary properties. It's decentralized, meaning no single person or company is in charge. It's public, meaning anyone can download the ledger and verify every transaction for themselves. And it's immutable, meaning the past cannot be changed without everyone on the network immediately knowing about it.
Okay, that was a lot of technical detail, I know. But what's the big takeaway? Why go through all this trouble to build such a complex system? The answer lies in the unique powers that emerge from this design.
This whole structure creates a system where you don't need to trust any single government or corporation. No one can secretly change the rules or just turn it off. Because it's transparent and immutable, you can trust the record itself without having to trust a middleman. And because there's no central authority, a valid payment can't be blocked or censored. This is the real power of a trustless system.
Ultimately, what was created with Bitcoin was the world's first global, decentralized, and trustworthy ledger for value. It was built to be a new form of money, but the underlying technology, the blockchain itself, is fundamentally a new way to create and share a trusted record of, well, pretty much anything. So the question we're all left with is, now that we have this tool, what else will we build with it?